Hello, this is Algebra II Math. Today in Algebra 2 we'll be looking at probability of independent and dependent events. So an independent event is where we have multiple events and the first event doesn't change the second in any way. Doesn't matter what happens during the first event, it does not affect the second. So one example would be flipping a coin and rolling a six-sided die. Whether you roll heads or tails is not going to change the probability of rolling a 5 with the dice. And our formula goes like this. Probability of A and B happening is the probability of A times the probability of B. Probability of a dependent event. The first event affects the second. So an example of a dependent event would be like you're drawing marbles from a bag, and they're all, let's say there's 5 different marbles with 5 different colored marbles in a bag, and say you draw out a red one for the first time and you don't put it back in. That first event would affect the outcome of your second event. Since you already pulled a red one out, then you can't draw a red one again. And how this goes is the probability of A and B, so both occurring simultaneously, is the probability of A times the probability of B happening given that A occurred. So that's the notation on that. So this is the probability. So the second one here. Oops, let me write that. So the one that I'm writing now is called the probability of B given. So that line there, it means given that A occurred. So this is considered. Let me change colors really quick. Conditional probability. That guy. That is known as conditional probability because one event affects the other. So let's look at examples here. A random survey that found that 46% of parents say that their kids read at least one time per week. If 3 parents are randomly selected, what is the probability that all 3 parents will say that their children read at least one time per week? Okay. So this is the probability of A and B and C. So that would be the probability of A, because these are all independent events. One set of parents won't affect another parent's outcome of having a kid that reads. So the probability of a parent saying that their kid reads at least one time per week is 0.46 or 46%. So the probability of the second parent having it is 0.46 times the probability of the third being 0.46. So that is 0.46 to the third power, which is 0.97. Or 0.097. So there is a 9.7% chance of that happening if they picked 3 parents from their survey group. Your MP3 player randomly plays 4 different songs from a playlist of 16 songs. What is the probability that you will hear your favorite song during the school week? So the probability of hearing that song throughout the week is equal to 1 minus the probability of not hearing it at all. Not hearing one day. Oh, and there's 5 days in the school week, so to the 5th. So that would be 1 minus 15, choose 4. So out of the 15 days, or no, wait. Right, we're looking for, sorry, I got myself confused. Not hearing your favorite song. So out of the 15 songs that aren't our favorite, we need to choose 4, and the total is 16, choose 4. To the 5th power, because it needs to happen each day. So 1 minus, all this will turn into 0.237. So there is a 70, this will be 0.763. So this 76.3% chance that you will not hear your favorite song throughout the school week, Monday through Friday. Alright, find the probability that A, listed person has blue eyes, and then part B, a male has blue eyes. Okay. So part A, okay, there's 35 males that have blue eyes, and there's 9 girls that have blue eyes, so there's a total of 44 out of the, do we have a total of number of people here? No, we don't. So if we add up all these, there's 200 people. So that would be 11 out of 50. Part B, we know that he is a male. So that means we're just looking at the top row here. So there's 35 out of 100 males. So that's 7 out of 20. So because we knew he was a male, that changed our probability, because we don't have to worry about looking through the females. We just look through the males. Out of the 100 males, 35 of them have blue eyes. So 7 out of 20 chance of selecting a male with blue eyes. You randomly select a card, or 2 cards from a standard deck of 52. What is the probability that the first card is not a heart and the second card is a heart if you replace the first card before selecting the second? So this is an independent event because we replace the card, it does not change the outcome of the second card. So we're looking for probability of not heart and then the second card is heart. Okay. So that means that is 39 that are not hearts out of 52 times probability that it is a heart, which is 13 out of 52, which is 507 over 2,704, which is 0.1875. So 18.75% of being your first card being not a heart, and then your second card being a heart, given that you replace the card after you draw the first. Okay, what's the probability of the first card is not a heart and the second card is a heart if you do not replace? Okay, so my first card is not a heart, so there's 39 out of 52. So let's say I draw a Jack of Spades. That means there's 51 cards left because we're not replacing it. So, but there's still 13 hearts left. So there's 51 cards left there. That's why the denominators are different now. Multiply them. You still get 507 up the top. And 2,652 now in the bottom. So there's a higher chance now. 0.1912. A 19% chance of that happening. Your teacher passes around a box with 10 red pencils, 8 pink pencils, 13 green pencils. If you and 2 people in your group are the first to randomly select a pencil, what is the probability that all 3 of you select pink pencils? Okay, so let's say you draw first. So out of the 31 pencils, 10 plus 8 plus 13 is 31. Out of the 31 pencils, you have an 8 out of 31 chance of selecting a pink pencil. And then one of your friends in your group, his turn. Now there's only 7 pink pencils left out of the 30 remaining. And now there's only 6 pink pencils left out of 29. Do some multiplication, and we'll get 0.0125. So the probability of that occurring is only 1.25% chance. So it's very low that the likelihood that you all randomly select a pink pencil is 1.25% chance. Alright, a study reports the following information. 69% of adults wear their seatbelts. 66% of teens wear seatbelts when the adult wears their seatbelt. 26% of teens wear the seatbelt when the adult does not wear their seatbelt. Create a probability tree diagram to model this situation, then find the probability that a teen wears their seatbelt. All right. So, we're going to draw a tree. 0.69, 0.31. So, adult wears a seatbelt. Adult does not wear a seatbelt. Okay, this comes from, it says 69% of adults wear their seatbelts, so the remaining 31% of adults don't wear seatbelts. So that's where that comes from. Now, if the adult wears the seatbelt, then it says that there's a 0.66 or 66% chance that a teen wears their seatbelt. Teen wears seatbelt. Okay, so there's a 66% chance. 100% minus 66 is a 34% chance that even though the adult is wearing a seatbelt, the teen does not wear a seatbelt. Okay, if the adult does not wear a seatbelt, they tell us that there is a 0.2, right? Yeah, there is a 26% chance that the teen does still wear the seatbelt. Okay, and then that means if an adult does not wear, 74% of teens do not wear. I don't know why I keep spelling teens T-E-A-N-S. I don't know why. Does not wear. Okay, just to review. Okay, so they gave us some information. They told us that 69% of adults wear seat belts. So I calculated that 100% minus 69 is 31%. So there's 31% of adults that do not wear. So the other information they gave is if adults wear the seatbelt, then 66% of the teens wear seatbelts. And then if the adults do not wear, then 26% of teens still wear the seatbelt. Okay, now we want to find the probability that a teen wears their seatbelt. Okay, so there's either two different paths that we can choose, because our goal is teen wearing a seatbelt. So there's one here, one path there, one path here. So I can go up to here, or I can go down this path and go here. Okay, to get to the upper one, okay, 0.69 of the adults wearing the seatbelt times 0.66 plus 0.31 times 0.26. .4554 plus 0.0806 is equal to 0.536. So there's a 53.6% chance of a teen wearing their seatbelt, regardless of whether the adult wears or does not wear their seatbelt. Hopefully this helps you out. Have a good day.